So that's a joke from my friend. How to imagine 3D. You draw it like so. Front is X. It goes front and back. 0 is a node or a pole. Sometimes they call it a pole. Then Y is this, left and right. And now we're adding height. Up is Z, down is minus Z. So that's international notation of the 3D coordinate system. And this is a joke to remember. What's up goes up, front X goes front, and to the right, that's Y, to the right. In American book, I noticed that they do this kind of way. X and Y, and then up. That is not international notation, so I don't like sticking to it. But you will see it, though. I think it's harder to operate with this notation. So what we did, basically, from the previous knowledge of Y and X, this is what we knew before. We take this Y and X and put it on the floor. So the floor now is Y and X. Z is height. Now X becomes front and back. Y is left and right. Z is up and down. Before, I like to imagining it with an ant or a caterpillar. The caterpillar was only on the floor, going left and right. Now there's a 3D object which is flying around. Say caterpillar became a butterfly, and now it can be anywhere. So it gives you more freedom to travel. That's the idea. On a 2D, the caterpillar would only go left and right, up and down, but on the floor. So we're adding the whole dimension, so that means caterpillar now can fly. So basically a butterfly. Let's learn how to operate. This is the important part here. Is this the right one? That's not the right one. Let's see. Oh no, I think it's fine. Yeah, good. This is how we're gonna operate with the notation. There's a point somewhere in 3D. You can just put it here. Point somewhere in 3D. We're gonna call it A, B, and C. What are those A, B, C? It is X, Y, and Z. Like so. So now there's a third dimension. Well, how to know what does it mean? A means how many units I'm moving on the x-axis from 0. Okay, if A is positive, I'm moving to the front. A. If A is negative, I'm moving to the back. So it's just negative front. Y is how much I go to the right, if it's positive, or left if it's negative. So I'm going to the right, if it's positive, to B. Finally, C is to go up. So that's now doesn't match the picture. C is to go up. And this is the point A, B, C. Like so. So this is how we're going to be doing it. The best is not to guess. The best is to start with X and Y, then Z. Front, right, up. And then if it's negative, then you go the other side. This creates a shape like this, which is giving us X can go to positive, Y can go to positive, and Z goes to positive, like so. A units in X direction, B units in Y direction, and C unit and Z units up. So C units to Z direction. That creates like a room has a box in the corner, a corner of the room basically, this kind of shape. So you can imagine the corner of that, of the corner of this room over there, it creates a shape like so. So basically your first homework will start with the very basic questions. I'm not saying they're simple, but the beginning is just to learn how to use coordinates, just like we did in school when they introduced coordinates to us. How to find 1, 2, and 3. So let me... Who is already yawning? We just started, so it's too early to yawn. 1, 2, and 3. Try by yourself first. Can you do 1, 2, and 3? So I don't spoiler it, and then you can actually practice. 1, 2, and 3. And then we're going to do all others. 1, 2, and 3. Let's try it. I think it's good enough time to think about. 1 towards me, that's 1. 2 towards y to the right, that's 2. And then 3 up. So it's keep growing. Every next step is keep growing. This is the point 1, 2, and 3. Does it make sense? So we then erase those lines. Lines are not existing. That just helps me to move. But then the point is 1, 2, 3. Does it make sense? Now it gets harder with negative ones. 2 minus 2 and minus 1. Let's change the color. 2 points towards me. So twice more. 1, 2. 2 points towards me. Minus 2. That's to the left now. So to the left. Minus 2. And then minus 1 up. That means 1 down. So it's negative 1 units. So it's 1 unit down. So I'm going a little bit down over here. And that's going to be the point 2, minus 2, and minus 1. Like so. And again, you erase all the lines. You just need a point. The point is what we're trying to get. Does that make sense? Can you do minus 1, minus 1, 1? Minus 1, minus 1, 1. Let me do it for you too. So minus 1, that's back, not to the left. You see, you first want to go to the left because that's what used to be x. Now x is front and back. Minus 1, back. Minus 1, that means to the left. And then 1 up. This is the point. And again, I'm erasing everything. And it becomes minus 1, minus 1, 1. Do you agree? So minus and minus, we're moving in the 2D. And then plus 1 moved it up into the air. So again, over here on the floor, the caterpillar is moving left, right, front, and back. But then Z tells the caterpillar to actually fly as a butterfly, up or down. That's what the 3D motion basically means here. Not too bad. The beginning is always looks like simple. It's always a bad sign, right? It means it's going to get harder after this. Okay, how to decide where Z is? Like, why do people decide that Z is going up but not down? How to know that? International people agree to use the right hand rule, which is, again, everything is towards right-handers. As a left-hander, I always get confused with this rule, and then I learned that all left-handers get confused with this rule. But physicists, I think, got used to it because you guys have lots of rules with right hand. So this is the right thumb up hand. You take your right hand, and then your index finger points at X. Then your arm is Y. When you fold from X, from positive X to positive Y, where the thumb is, that should be Z. Your thumb is the positive Z. It sounds very unreasonable. Why we even care about that? Because the 3D can be moved. The 3D rotates and flips around. So Z is not always up. Z sometimes will be towards you. That's the whole point of having a 3D object. It rotates. So the whole point to learn is you take X with your inner finger. In my country, we use the whole hand. And then you fold X towards Y. Then Z will be where your thumb is pointing. If X goes here and Y is here, folds, and it's down. If like so, then towards here. If like so, that's what we're learning right now, then up. So at this moment, we learned only one way. Check it out. My fingers are going towards my hand. If positive X went to positive Y, then the thumb tells you where the Z is. But make sure you use right hand, not the left hand. So it's not a leading hand all the time. If you're a left-hander, you know what I mean. One of the bad evaluations says, I did not do well in her class because she was a left-hander. When she was writing, I could not see what she was writing on the board. Just letting you know, that's not going to change either. So if you don't like that, you have to change the class as well. So you will see that it's not going to be that crucial, but it's pretty practical rule, and everyone knows this rule, which is a pretty cool idea. Coordinate planes for people, for like us, we all know how the room looks like. So it's nice to imagine that whatever used to be 2D now is a floor. So X and Y axis create the floor. And now there are walls showing up because Z gave us height. Now Z and X create a wall, let's call it left wall. And then Z and Y create a right wall. And that's only one case. How about going back? How about negative X? So back, not front. How about negative Y? And how about going down? This is just one sector of the whole object. And that is called, using planes, we're dividing the whole universe into those objects, octants. We're going to call them octants. So it used to be quadrants, first, second, third, and fourth. Now we have octants. Let's see how it works. And that's going to be very tricky to imagine this. So if you have good imagination, good for you. You will like this. If you're not, you will develop some. You don't really have a choice here. So the x-axis is just a line. But in 3D, now it has a wall. Because x-axis as a line now has infinite height up and down when z is 0. So now it's a wall. Thus, all others are also walls. And when they intersect, let me show you beautifully, like so. When they intersect, they create cool objects. It may be a line or maybe a point. So we'll see that. That's what we call here. This left wall is created by x and z, so it's xz plane. Plane. That's okay, not too bad. YZ plane. Because it's created with y and z. Order doesn't matter, but usually people put letters in order of alphabet. XY plane. And we used to stay in XY plane. Now we moved to the upper dimension. So you see it here, all of those planes. But again, it goes farther than that, of course. You should understand this wall is keep going. That's why in this picture, there are only positive parts of the planes. But it's nice to imagine the room this way. So here they are. Here are my planes. We will be asking you to draw them and to explain how they look and find intersection of this kind of plane and this kind of plane. Let's see what it means. Remember, very simple. Let me show you this. XY plane, that means whatever is missing is 0. Because whatever is missing shrink to nothing. Z is not here, so Z is 0 for XY plane. Let's check if this is true. XY is the floor where we used to be all the time. If there's no Z, we're going to 2 dimensions where we've always been, X and Y. But having no Z means Z is 0. Same as YZ. Whatever is missing is 0, so X is 0. Let's see what that means. Y and Z plane. Let me go to the screen and show you. Y and Z is actually the easiest one to remember. It's exactly this projector wall. See? There's no front and back. If X is 0, there's no front and back. It's exactly this projector screen is Z and Y plane or YZ plane. Do you agree? No front and back. The moment I'm adding this pencil, that is my axis. That creates 3D. But this one is 2D. Because X in this case, as front and back, shrinks to 0. So it used to be 3D and then we shrink to a plane. That's what it is. Finally, the last one is the hardest one to imagine somehow. Because it's X and Z plane. Y is missing. That means left and right does not exist. So that is this one. But it's kind of hard to draw and imagine. So I think this is the good way to explain it. Y is left and right, shrinked. And now we have just a plane. It's easy to remember that whatever is missing, that thing is 0. Does that make sense? What do you think? Okay, people are nodding. That's not too bad. First octant, check it out, it's beautiful, that's what I was telling you. This room representation creates a first octant. this is a room, right? This room will be called first octant. The first octant, by the definition, please write it down. X, Y, and Z are positive. That's called first octant. Used to be quadrant, right? That is analog of the first quadrant, but in 3 dimensions. Let me remind you, in 2D, we had quadrants. First quadrant, second quadrant, third, and fourth. It goes counterclockwise. The first quadrant means X and Y are positive. So we're following the same logic here. X, Y, and Z are positive. So it's only front positive, only to the right positive, and only up. We don't go back, we don't go left, and we don't go down. That creates first octant. Guess how many octants do we have? We used to have 4 quadrants. So how many octants they are? 8. How did you see that so fast? Let's see how many cubes I can put. I can put 1 more cube to the left, 1 more cube back to the left, back to the front, and that's only on the positive side. Now I do the same thing at the bottom. So there are totally 8 of boxes that create these 3D coordinates. Does it make sense? 8. There are a total of 8 quadrants. Write this down in 3D space. And let's practice writing down the points. That's a very good thing to do. Let's do it together. First octant, totally, let's write it down. 8 octants in 3D space. So if this point in the middle is called 0, 0, that's too fat. 0, 0, 0, no x, 0x, 0y, and 0z. And then we have ABCs in each way. Let's learn how to actually name the first octant. Can you tell me the name of this point? That's up to you to think. This point has a coordinates. What coordinates is that? 0, 0, C, right? Let's Z or whatever. So Z, C, let's call it C. Let's see Y. This point is located on the Z axis. Whatever is missing is 0. There's no front and back. That gives me X to be 0. That's X. There's no left and right. So that's also 0. That's Y. But there is something positive up. Let's call it C. Does it make sense? This is the first point. How about this point? Who wants to tell me this point? 0, B, C. Let's see if we agree or disagree. Disagree? Let's check. So I see it goes to the right. Oh, so first you check front and back. Front and back, I don't see it going front and back. It's at this wall. So it did not move towards me or away from me. That is 0. But I see it went to the right. Let's call it B. And I see it went up. Let's call it C. Make sense? Let's see. This one. Anyone? A. Let's see why. Because A went to front. It exists. Then, do we have anything left or right? No, that's the y-axis. So that's 0. Do we go up or down? No, so z is 0. And so on. That is the idea. And the most general point is this one in green. Let's call it P. P is usually a nice representation. What do you think is the coordinate of P? A, B, C. That's the most general case. A, B, C, because this point definitely is in front. The center is back to the wall, right? So it moved to the front to me. Then it moved to the right. See, it's to the right. And then it moved up, right? So ABC is the most general case of the first octant. And so on. You can finish the coordinates. Actually, I have them for you here. Here they are. So to get this general point P, you go towards me, to the right, and up. This is the example. I made a screenshot from the book. As you can see, American book makes the visual a little bit different. I think it's also from your homework in web work. How axes are represented. It's the y-axis is not straight. In American books, I can see they're doing it at this angle, which to me is harder to work with. So I'll be mentioning it just as a reference, but I don't use them. I asked actually Europeans and Asian students. None of them have this shape. So I think it's only American books doing that. And I think it's make it more complicated. Okay, let's do it. Sketch the surface. What is x equals 3? What did you say, plane? Why not a line, though? X equals 3 sounds like a line. Yes, no? You have to be confident. Like, you cannot just switch because I don't agree with you. That's the whole point of being confident. Self-confidence. Promoting self-confidence in this class is important. So, imagine 3D. All of this is spinning. You can look at the objects in all kind of dimensions. What is x equals 3? X equals 3 in 2D is just going to the right 3 units and no height, right? So it used to be a line. The height is anything you want, but x is fixed as 3. So then we're taking it to the 3D. A line in 3D. Let's see how it looks like. Pretty cool idea. So, just like you mentioned, let's go through 2D from 2D to 3D. In 2D, and I'll be using 2D all the time to make a link between what we learned in calculus 1 and calculus 3. X equals 3, if you don't remember, you go to the units 3, and now, no matter what point you have, x have to be 3, but y is not fixed. Y is not missing, it's not 0. Y is anything. So x equals 3, y is anything. That means y can go up and down. This is a line, x equals 3. That's how you see it, 3 units to the right. In 3D, let's learn how to sketch it from the beginning. Finally, let's learn this. Let's draw z. Actually, let's start the correct way. Y, x, z. This is how you usually sketch it. And usually people put dots to the negative sides, like so. From the start, you sketch it this way. Now, x equals 3 means I'm going to 3 units towards me, right? And then everything else is arbitrary. Not y is any, but now y is any and z is any. This is any. Anything you want. Thus, y can go to the minus and go to the plus, right? That is a line. But then do we have z or not? What do you think about that? Z. We have it, right? It is somewhere. So how to show it? I'm gonna increase or like stretch this line up and down. I'm stretching it up and down. What's the name of the shape? It's a plane. Yeah, good job. Very good. See, you should be confident. It's a plane. Plane. So, be careful with the idea of having x equals 0, y equals 0, or z equals 0, or x be any, y be any, and z be any. That is not the same thing. So, your point is to always try to understand the difference. Any means it can be free to go anywhere it wants. That is the idea here. While if it says intersection or it says that z is 0, then that is a restriction. Something is 0, that is a restriction. Let's move on. How about this pretty cool object? Let's try to draw or imagine other stuff. What is x plus y? X plus y is a line. I remember in 2D, it looks like this. Quickly, you have x plus y equals 4. It's usually like a triangle looking thing, right? So it is kind of like this. You can always check, this is x, this is y. When x is 0, y is 4. When y is 0, x is 4. This is a shape in 2D. X plus y equals 4. Now z is missing, but it's not 0, it's any. So I will take this shape and do what? Stretch it up and down. But now from this 2D graph, it's not very clear how to do that. We have to draw it properly in 3D graph. So let's move it to 3D. Z is any. So in mathematical notation, any, if it's all real numbers, is this notation. Z is upside down A. That is international math notation for any Z. You don't have to know that, just letting you know. So let's draw it from scratch. X goes towards me, center. Y goes to the right. Z goes up. X, Y, Z. This is how you draw a 3D coordinates fast. Now it's not very obvious how to put this line into 3D. The first graph is my floor, right? But now my floor is tilted towards me, kind of very not clear. So let's draw it from the scratch again in the same color. X and Y. X plus Y equals 4. When Y is 0, X is 4. When X is 0, Y is 4. So it is this line. This is the line. X plus Y equals 4. Now Z is there. Z exists. Z stretches this line up and down, right? So I'm gonna take it and stretch it up and down. So it has a height now. That is a plane. It's a plane parallel to Z axis. So it is a plane in 3D. And the equation of this plane in 3D will be like so. We know that it is X plus Y plus 0 times Z equals 4. That's the big difference. We're introducing a third dimension, so it is there all the time. But if you don't see, it's multiplied by 0. Multiplying by 0, it means Z can be any. That is the idea. Since Z represents height, height can be any, positive or negative. So the line becomes a plane. That still makes sense, to be honest, because in 2D, it's a line. In 3D, it stretches to next dimension. Whatever was so tiny and small becomes next dimensional. That's a plane. A plane in upper dimension is a cube, right? So it stretches. First, it has no depth and no height, just run and rise. Now it has height, and then the next dimension is depth and becomes a cube. So in general, again, in the American book, they show it this way. They somehow tilting it to the right. Super not convenient. Nobody does it this way. So I don't like it. But the idea is, see, there's a plane. It's cutting through the floor. On the floor, X plus Y equals 4 is a line. So in 2D, originally we were doing all the calculus last semester in calculus 1 class. We taught you guys what slope is, derivatives, all of this on the floor. And now we're going to move it into height, 3D dimension. So the plane cutting through the floor gives you a line that makes sense. What do you think? It's basically a shadow. Check it out. It's a shadow on the X, Y, and Y plane. The shadow gives me this line, which we always knew before. X plus Y equals to 4. That is a new thing to understand. Finally, the most important is a formula. In general, the formula of the plane in 3D is A times X. A will be the slope that belongs to the X-axis, right? So how far my X is stretched or shrinked. Slope, remember, rate of change has some connection with derivative. Plus B times Y, that is the slope or rate of change of Y coordinate or Y-axis, which is left and right. And then finally up and down, this is the slope for Z, equals to D. D is some kind of number at the end. We will show you how it goes up and down. The whole plane can be flying up and down. Put this in the beautiful box. I like rainbow boxes. Let's put it in the rainbow box. Here it is. So A and B and C are those numbers that tell me the slope, the steepness of the plane in different directions. Plane in 3D. Make sense? One more formula is the distance between points. How about that? The distance between points is basically going to be the same thing. In 2D, it was on the floor. It was this point, the formula was the square root. You don't have to be upset if you don't remember. The square root and then change in x and change in y, both squared, comes from Pythagorean theorem. In 3D, we're just adding one more term. So the distance in 2D used to be just on the floor, x and y, and here's the distance between this point and this point. But now we have distance in 3D. 3D, there's a point in the air, like a fly flying in the air. How far you are from the fly, and you want to hit it with the newspaper. Here it is. You don't have to know all of these. I will where did you go? I will highlight here. I will highlight only those you need to know. You need to know the 2D case, distance between points. 2D case, usually we call D, but you don't have to. Is square root x minus x squared, y minus y squared, right? And then the different x's and y's inside. One is the original point, the other one is not the original point. In 3D, you just add one more dimension. And that's going to be a cool thing where we'll start doing calculus. Lots of things will just add one more dimension before it gets crazy. It's for now, it will be pretty straightforward. Using this formula, you just find distance between points. Not so much to do. So this is kind of the very classical homework problems. Find a distance between 2 points. You just remember that you put difference between corresponding points. Since I highly recommend, so find the distance between point -7, 4, and -2, -4, 10, and 4. Is it too fast, or you think it's fine? In first class, I usually think, someone said it's good. The first class I go fast. It's usually introduction to something new, and it goes fast, and then it becomes harder. X, Y, and Z. I highly recommend you to sign everything with a pencil. X, Y, and Z. And now the order doesn't matter, just be consistent. Because it's squared, you don't even care where is the beginning and where is the end. We will care on Thursday, but not today. And you put it in the formula in any order you like, since it's squared, doesn't matter. But I do know that there's a huge square root, and it's going to be x minus x squared, so -7 minus 4 squared plus 4 minus 10 squared plus -2 minus 4 squared. That's it. Good enough. Can you do that? So we're just adding one more dimension, nothing really new. Then we go into something awesome like a spheres and other shapes. What is the equation of a sphere? Equation of the sphere is just improved equation of a circle. Circle was in 2D, it's flat, and then we're adding shape to it, depth. That gives you a sphere. Here's how it looks like. It looks beautiful. But if you collapse it in any direction, you will see a circle. It's flat. It's a circle. If you collapse it from this side, you will have a circle too. If you collapse it from up and down, you will have a circle anyways. So any dimension you collapse, the other two creates a perfect circle. General equation of a sphere. This used to be a circle, right? X minus a squared, y minus b squared equals r squared. Used to be a circle. Now we're adding a depth to it, or height, whatever you want to see it. Z minus c squared. That's a sphere centered at A, B, C, and radius r. That's important. How to draw a sphere? People who are not very good at drawing, I can show you. You draw a circle first, and then you do a front, and then dashed back, and put a center. That's how you draw a circle. That's how you draw a sphere. You draw a circle, and then you add the depth to it. That's the idea here. Finally, checking. Finally, we draw several things. So if we ask you to draw a sphere 1, -2, and -3, knowledge number 1, we just learned how to draw a point. So that's a center. You draw a point. So you first have X, Y, and Z, right? Get used to this 3D axis and draw them fast. Then you need to figure out the point, and that's why we keep improving. We figured out how to draw a point. We figured out how to draw a line. We figured out how to draw a plane. Now we figured out how to draw a sphere. So we keep increasing the knowledge, literally in class 1. Point 1 on x-axis. So go to 1 minus 2 to the left or to the right? Left, 2 units. Minus 3 up or down? Down by 3 units. So that is the center. 1 minus 2 and minus 3. That's very hard to read. 1 minus 2 and minus 3. That's a center. Now it says radius is 4. So I need to go 4 points each direction. Like a flower, basically. Or lasers all over the place. You go away by 4 units. This idea of lasers will be extremely important on Thursday. And I'm creating for a circle, and then I'm giving a depth to it. Depth to this idea. So a circle, 4 units away, and then depth also 4 units away. Not very pretty, but I just wanted you to know the idea. Does that make sense? Now the question for you is, what is this object? Let me move it. What is x plus 4 squared plus y minus 3 squared plus z plus 1 squared less or equal to 9? What is that? What do you think? It's a solid sphere, a ball with stuff inside. So a sphere is a shell. It's basically a soccer ball, which is, by the way, a football ball, because you play with a foot, right? So, and then it's empty inside. That's a sphere. It's a shell. But if I put inequality, now I'm filling it in. And if I put equal as well, I'm also including the shell. So that will be calling a closed ball, because this is inside of the sphere with a given center and a given radius, and we're going to call it a closed ball. That's official terminology, internationally accepted. If you don't include, if you only say it less than 9, then it will be just whatever is inside of the ball, say the air or water, if it's a water balloon, with no shell. Then they indicate the outside with dashes. But usually we include it, so it has a physical interpretation. So this is a sphere, just like we drew before, with everything inside of it. So we're filling it in with something. So inequality gives me this opportunity to go to some physical interpretations, to have physical objects. Does that make sense? How about this? Finally, last challenge, I think, should be good enough. Maybe not, we'll see. Sketch the region. What is x squared plus y squared plus z squared between 1 and 4? What does your imagination tells you? Between 1 and 4. Yes?
A sphere with like a hollow ball.
A sphere with a hollow part inside. What do you think? A sphere and a sphere, right? Yes. And then something is happening between those two. So draw. So you should understand that this is one sphere. And then this is another sphere. That's just kind of the idea here. You draw 2 spheres and then see what's happening. The first sphere has radius 1. So x squared plus y squared plus z squared equals to 1. And the second sphere is x squared plus y squared plus z squared equals to 4. Those are spheres with nothing inside. Inequalities are not taken into account yet. So I definitely gonna draw x is a front, y is to the right, z is up, 0 is inside. Center is 0, 0, 0. Lucky, we don't have to move anywhere. And I have a sphere with radius 1. Remember, draw a circle first, then make a depth out of it. That's a sphere number 1 with radius 1. Change the color. I like using colors, as I mentioned before. Bigger circle with a radius 4, make a depth out of it. Now I have these 2 circles. So what should I do with 2 circles? It tells me that we should only take space between 1 and 4, right? So I have to be bigger than 1. Inside of this green sphere is less than 1, right? So I need to go out of it, outside of the smaller, but inside of the bigger. Gives you the difference. Do you agree? It's a space. It's a filled-in ball, but with a hollow piece inside. Does that make sense to you? What if I tell you that I only need that in first octant? That will be the most tricky part in the tests and in your homework. You were so sure you were right, but then you see, oh, they want a second octant. Who cares? Yeah, so we will be training you. What if we only need it in the first octant? That gives you one more important condition. X and Y and Z must be positive all the time. Positive or 0. We don't need the whole 3D shape over here between 2 spheres. We only need them to be positive. Do you know how to draw this or how to imagine it? Highlight the positive directions like so. And now imagine everything is only in the first octant. In the beautiful representation, it looks like this. They cut off the big sphere and they cut off the small sphere and only left the positive parts of those spheres. And then they took the area between those. Does that make sense? Pretty interesting and kind of challenging to draw. But, doable. Questions about this? What do you think about that? Questions, ideas, suggestions? Definitely email me if you don't feel comfortable about something. Especially colors. I'm always concerned and I'm using so many colors. And then there's a student who doesn't see any. That will be like really not fair. So that is important. Finally, let me show you this. And I do like to show lots of animations. So I definitely always prepare lots of cool animations. So we went from the line to the plane. Again, if I ask you to sketch the region y is between 2 and 3, that is a distance between 2 planes. You draw 2 planes, right? And you need to know how to draw them. They are on the y-axis. So z and x collapsing to 0, y is 2. So y's keep changing, right? Then the distance between them, the difference between them, will be those 2 inequalities. That is important. We covered this, and then first octant, cylinders. Cylinders will be everywhere, and cylinders are coming from the circle. Guess how to create a cylinder from a circle. Let's draw this, last thing to draw in 4 minutes. How to create a cylinder from a circle. What is the difference between a cylinder? I imagine it's just a tube, right? So let me show you. Cylinder has Y in it, don't forget. Cylinder. Do you know what cylinder is from a mathematical point of view? Can you guess?
Circular prism.
It's a circle. I like the word circular because I know that it's a tube and it always has a circle on every level. So I will draw a circle, right? And then what happens to the circle? It grows up and down. And that's how we imagine a cylinder. It's a tube, but it's basically a tube filled in with circles. If you remember in calculus 2, we were slicing things with discs, so we had cylinders before. It's not new. If you don't remember, it's fine. But in general, it's a circle that is now moving up and down. Z direction happened. It's height. So the circle equation with x and y is x squared plus y squared equals r squared. R will tell you how wide the circle is. And then the z direction happens. Z direction. That is a standing vertical cylinder. Well, why it's vertical? Why it's not lying down? Why it's not a tube that's lying down like this? That's also a cylinder. But in this case, it's going to be x squared plus z squared equals r squared. And y is going to be this height. So y is telling you which circle should be keep moving. X squared plus z squared is keep moving now. Left and right. So in general, the rule is cylinder has an equation. If a variable is missing, if a variable is missing, then it's a cylinder. It's a cylinder. And the missing variable tells you which way it's growing. If z is missing, it's going up and down. If y is missing, it goes left and right. If x is missing, it goes front and back. That is the idea of the equation of a cylinder. I like to teach intuitive ideas because then you can definitely have some intuition how it was drawn from 2D into 3D. Yes?
How would you draw it if x is missing?
If x is missing, so check it out. Actually, good question, right? Let's make good notes. X, y, and z, that's when we have z and x. That gives me this circle. And let's keep going left and right. So up and down for the first example, left and right for the second. I forgot how to write during this break. Right. So guess what's going to happen if x is missing? I'll draw the same coordinates. And now I only have the floor. Let's see. X, y, and z. It's going to be towards me. Like this. Towards me and back. If x is missing, which is y squared plus z squared equals r squared, then everything else is changing, but x can be anything. So it's going to be towards and back. Does that make sense? All three cases. Good job, people. If you have any questions, come right now, talk about that. Don't forget you have homework due Monday in web work. Everything is set up. I will see you on Thursday. Don't be late.